A golfer hitting a golf ball off of a tee, and the golf club will give that golf ball an impulse. It'll provide a force over a time, and it'll get that ball up to speed. It'll get that ball all the way up to 38 meters per second by the time it reaches its maximum velocity off the club. Now they give you the mass of the golf ball. It's 0.045 kilograms. And the question is, what is the change in momentum of the golf ball? So question A, we want to find the change in momentum. Well, since momentum is mv, change in momentum will be mass times change in velocity. Again, we have to watch our signs. Now, again, the golf ball was not moving initially. So my initial velocity was 0 for that golf ball. And as a result of that impulse, as a result of that collision, its final velocity ends up being to the right, positive 38. So when I write my equation, the change in momentum of the golf ball is mass, 0.045 kilograms, times my change in velocity, which is final, minus initial. And when I sort that out, I end up getting 1.7 Newton seconds, or 1.7 kilogram meters per second. Those units are equivalent. And that change in momentum is to the right in my diagram, so away from the club. Now in part B, they want to know the impulse. So in part B, we need to know the impulse because now we want to determine the average force applied to the ball. So the idea is that in any collision or explosion, we can use our conservation of momentum equations, or we can use impulse equals change in momentum. Now we know there's two formulas for impulse. Impulse, by definition, is an average force applied over a time. And it's a vector. So my impulse is always in the direction of the force. Or impulse is equal to change in momentum. They're equivalent. Well, I've already got my change in momentum. My change in momentum is positive 1.7. So I actually know what the impulse is. So now when I go into my impulse is force times time equation, I know what I is. They tell you the time of contact with the club is 0.003 seconds, and I'm searching for the average force. So my average force will be impulse divided by time. My impulse is the change in momentum. It's the same thing. And my change in momentum was 1.7 kilogram meters per second. And if I divide that by the time of contact, which in this case was very short, 0.003 seconds, I get a force that acts on that club of 570 newtons, also away from the club, or to the right in this case. And again, I'm just going to make a quick little note here that if the ball experiences a force to the right of 570, according to Newton's third law, the club will experience an equal and opposite force of 570 back. Something to keep in mind.